This spot right here dates back to the 1820s, where there was a salt works set up here. Some brothers from Ipswich, the Tudor brothers, used an old Dutch-style wind turbine to pump seawater into vats. And this seawater would be pumped in the vats, and in the winter, when the seawater froze, the salt would separate from the water, and that salt could be harvested to pack fish before refrigeration. So it was a pretty big operation here. And then as recently as 1984 to 96, just by that mound over there, there's a mound, on the other side there's a concrete footing. There was a smaller 40 kilowatt size machine, and that machine fed directly into the high school. So for those of you that are learning some of the terms, that would be called behind the meter. So what the turbine would generate would offset what the school uses during the course of the year. And that was in production for 12 years and saved the school roughly $74,000 in electricity in those 12 years. That was taken down, as you can tell. This is, like I said, pretty windy spot. And although it served a very good lifespan at 10 or 12 years, it was one of the older machines that, unlike today's modern beauties, they were really beat up by the wind. They were blown around, they were driven by the wind. This one actually is an upwind design. The other one was a downwind, so very mechanically, a lot of mechanical features instead of more electronic like this guy. So it was decommissioned in '96, and a bunch of the citizens in Hulls formed a group called Citizen Advocates for Renewable Energy and worked, as you'll see here, after we're done here, we're gonna go and meet with some of the good townspeople, the selectmen, the light board. Hull has their own electric company. It's called Hull Municipal Light Company. And so that made working on this project a little easier. Instead of working with a big company like NSTAR or National Grid, it's kind of homegrown and local. So what we see here is a Vestas. This is one of the most popular machines out there even to date. It's a V47, which the 47 denotes the rotor diameter in meters, so it's about 150 feet across. And it's a 660 kilowatt unit. That means at full output, around 24 miles an hour, it'll put out 660 kilowatt hours per hour. So in the course of the day, we've had 24 hours of full output. You'll get over 15,000 kilowatt hours, and that's pretty substantial. Over the course of the year, this machine puts out 1.5 million kilowatt hours, or 1,500 megawatt hours. And again, that has, you know, a cost savings to the town associated with it. People ask, you know, if it's not windy, do the lights go out? And that's not the case. And if it's too windy, do you export power to the big grid? And right now, that's not the case. We're at the end of the distribution system. And did you guys see the big machine coming in? Yeah. That's at the beginning. So it's quite interesting that you have these two wind machines that kind of bookend the town. And again, people are real excited, especially coming from yesterday's event. Yes?
What's the capacity of the big?
Yeah, the capacity of the other machine, that too is a Vestas. It's a V80, so it's got an 80-meter rotor diameter, and that's a 1.8 megawatt. The time that went in, it was one of the largest machines in the United States. Right now, there are larger machines going in, but and this is a 50-meter tower. Sure, the average capacity factor, to let you know what a capacity factor is, it's like a hitter's average in baseball. Every time that Big Papi gets up, he doesn't hit a homer, sometimes he strikes out, but what's the average? This machine is about 28%, between 27.5, 28, and its availability, did you hear some, again, these are some terms I don't want to just throw out there, but to get you familiar, the availability of this machine, during the course of the year, how much is it available to generate, is like 98.6. So we've had very good luck with this machine. Both machines, it's pretty interesting. This is a 660, that's a 1.8, and so that's about 2.7 times the production output. This machine has been installed, it was installed in 2001, and that machine in 06 to date about 11,000 megawatt hours, and that machine is soon going to eclipse 11,000, and so they're going to cross each other on the graph, and that guy is going to be ahead. It's a constant RPM machine, so it always rotates at 28.5 RPM. Of course, when it's starting up, it's going to be slower, but during its entire output range, and that's done through blade pitch. So the blades actually pitch on the nose cone, and they just like a sailboat to allow more or less of the wind. When the winds pick up beyond 25 meters per second, the machine shuts down, and we'll stop back up when the winds die down to a more manageable rate, more manageable speed. We've had some maintenance on it. We've had a generator replaced. We've had the blades. Some of you folks were here in this fall, and we had some folks that were actually, the tour that was here came a little later. We had Harvard here earlier in the day, and there were people actually on the blades with rappelling gear doing repairs, and as you can imagine, it gets nicked up and dinged up, and we've actually had a lightning strike. Yes?
How often do they do the repair or maintenance?
Well, they do annual maintenance annually, once a year, and then if there's any, when we get inside, and we'll get inside soon, I promise, not holding you hostage here, you'll see it's a very, you know, the controls on this is, so not only the controls, but the SCADA unit, the supervisory control and data acquisition, will signal an office in Albany if there's anything, in here in Hull as well, but if there's any major problems.
Is the maintenance crew somewhere nearby?
No, they're out in Albany.
Oh,
Yeah, they're far away. Yeah, they do sub out some work, but how about some brief questions at all, and then we can start shuffling people in.
You say availability, you say 99%. It's they're ready to run, or it's actually running?
They're ready to run. They're ready to run. Oh, sorry. Yeah, availability. What does that mean? What's the availability factor? It's just, you know, how often is the machine available if the winds are there? So things that would affect availability is down for maintenance or other, maybe the winds are too strong.
So as a follow-up question, how often is it turning in terms of percentage?
Well, that's a good question. That's not a figure I really have. All right, so the question is, how often is it actually generating some sort of energy? And the better parameter to use is capacity factor, because truthfully there are times when it is spinning but not generating. The winds might be around 3.5 meters per second, just around the cut-in speed. So that's a cut-in speed is the speed at which the winds are high enough to where the machine is actually connected to the grid and generating. Up until that point, it's kind of thinking about it, but not really generating.
What's the cutting?
Cut-in speed for this machine is about 3.5 meters per second, 8 miles an hour. Yes? It's AC. What's coming down the tower is, so what's the voltage coming down? I'm just repeating the question. It's 960 kV, 690 volts, and it gets stepped up to 13.8 right here. 13.8 is the distribution voltage of the town. And basically, if you look right across to those power telephone poles, you could see some some conduits coming out and then attaching. Those are the actual connectors, and it goes right underneath the football field to the town. So, yes.
So you mentioned capacity factor of this machine. How does it compare to the other larger machine over there, which I see running less often than I see this one?
Sure. So the question is the comparison between the two machines. The capacity factor of the Hull 2 is a little lower. It's probably about 24%, 23%, and we're not sure if it's due to poor sighting or it's inland a little bit, because it's actually on a 60-meter tower, which is on a 20-meter high landfill. So it should, for all intents and purposes, be at least the same, but maybe because this is less exposed, less exposed. It's the end.
Can you estimate what the miles per hour is that we feel right now? What's going on up there? What's the average?
Sure, and we can take a look when we go inside. But I would say it's probably about 8 or 9 miles an hour right now. If you look at the back, there are wind cups. There's an anemometer in the back, and we can still see the individual cups. It's probably around 7, 8, 9 miles an hour. Once you can't start seeing them anymore, it's above that.
The cutter speed is kind of thinking about generating power. So does that mean the blades are turning, or it's just kind of on, or it's off?
It does mean the blades are turning, and probably fully exposed to the wind, so they're really flat, kind of like they are now. Yeah, and once the wind speeds kick up, and you can hear it. If you're here when you can hear the generator actually, make the connection. It's a donk.
Logistically, how did you get this unit in here?
Right.
And the other units?
Sure. So logistically, how to get these units? They came by big, oversized flatbeds. As a matter of fact, there should be some video on the Hull Wind site that show the machines traveling. This machine was in about 3.5 years, okay? But you've got to also realize that's due to a number of things. When Hull purchased this machine sometime in 2000, a 660 kW machine was actually put in for 780. So that's about 1,100 a kilowatt or 1.1 a megawatt. Those numbers have doubled easily now, and that's due to material costs, turbine supply and demand. But the new machine was about $3 million to put in for a 1.8, and 750K of that was the foundation alone. So.
When you picked the location, did you do any wind measurements, or did you do
Right.
statistical analysis?
So was there were the wind? Yes.
The plane was actually behind here.
Boss, the plane. Isn't that funny that the windmill's quiet and the plane's loud? So the question was, what was the question?
If you took any wind measurements?
Yes.
Picking the location?
Okay. Yes. As a matter of fact, we did have a Met Tower or an anemometer at the school. Plus, we had data from the older machine. And what happens is you can correlate that with Logan. So we used data from Logan. And those same folks, for those of you that were at the presentations or conference yesterday, Jim Manuel, John McGowan, those guys, they're just like super experts. It was their team that helped not only the wind studies here, but also for Hull too. And the offshore. Again, I don't want to tease you with the offshore, but we got folks later today that are going to speak about the offshore, so I want to save it for them. Don't want to. Yes? Lightning? Yeah. So lightning, okay. Lightning and icing, and we could talk about all that stuff. There are arresters on the blades. First of all, it's pretty well grounded, but there are arresters on the blades that are grouted in, and we have had lightning strikes, and basically they take the brunt of the strike and pop out and have to be kind of poked back in and regrouted. As far as icing or other environmental type activity, we have had one event. The machine is has a cold weather package. It's a marine cold weather package. And we have had one icing event, but not on the blades, on the wind cups, the anemometer in the back. During a cold rain, temperatures like this had a freezing event. So the machines are one set of information coming from the generator and another coming from the anemometer, and they didn't jive, so it shuts itself off and de-ices or defrosts the anemometer.
Do you have de-icing on the blades?
No, we do not. No, there are coatings. As a matter of fact, I definitely suggest that you folks, if you're really into wind, in May, the first week of May, I think it's the 1st to the 4th, in Chicago is this year's big American Wind Energy event. Last year there were 13,000 people. So if you thought the wind event at MIT was big, and it's great because I think there have been a few times that the federal tax credits have kind of have gone away or have not been updated, or so now that there's a longer term 5-year extension plus all of these other great policy changes, that I think the mood will be really good, and when the mood's good, all the parties are really good, so that's why I would go. Plus it's Chicago, right? How do you, I'm sorry, someone over here?
Yeah, could you talk a little bit about the foundation? I was expecting a big
Yeah.
slab of concrete.
Sure. Well, it is a big slab of concrete.
It's all going down.
Yeah, it sure is. It's about 12 feet down. It looks like a big stop sign. It's an octagon or octagonal, and it's a spread form, okay? And then through the middle, you have this retainer ring that comes up and is inserted during the process. On the hull site, we've got some pictures of the construction crew. Lot of rebar. The tough thing initially with Hull 1 was there was another big project going on in Boston at the time, right? The Big Dig. So finding concrete and rebar was a little difficult. The second machine actually sits on top of a capped landfill. Now we have a lot of landfills in this country, and probably gonna have a lot more. So if we're think ahead, maybe we put the foundations in ahead of time. But plain. Not enough methane. The landfill is being vented, but there's not enough methane to make a difference. And that's on 70 stanchions or 70 piles that were driven down. So it's pretty stable.
So this foundation is actually bigger than what we're seeing here.
Yeah, this is much bigger. Yeah, it goes. It's quite large. Quite large. Yes. Yep. Right. This is Marco Pesceria. Marco and I have recently formed a nonprofit called Action for Clean Energy, and we just this past week received 501c3 funding or tax-exempt status. So we can really go after this sort of activity, and more than just wind, we'll look at doing solar and biofuels. Again, I don't want to ruin it for later on's presentation, but we're looking at doing some tidal out in this channel. And again, we'll go over that in a little bit. We're not too far along, but you know, it's more than just the concept. We're going to be doing the resource assessment, and so that'll be exciting. And it's more than just you know, the outreach part. Hopefully, we'll affiliate with folks that'll be performing the installations, partner with folks that'll help attract investors for these projects, as well as the great educational institutions in and around New England. So it's really exciting. We've got some folks here from Harvard's Extension School. Their environmental management program has been very supportive, and just an exciting time, right? It's no better time than the present. How about we open her up and start getting people in? And all right. Awesome.
Simple design.
Yeah, well, the Europeans have done some great stuff. And GE is doing stuff, you know, good work as well. But
now, how do they address the question that a concerned citizen will ask, what's the chance that the plate will just detach, mechanical failure, and they just will kill everybody around? What do they answer?
I think it's probably pretty slim.
The turbine shut down itself?
Yes, 50 miles an hour.
Do you have plans for more?
What's that?
Do you have any plans for more installations?
Yeah, we're gonna learn about that later at the lunch, at the little.
You know what? I'm going to make a suggestion because so many people, but just point out the key features, and then we can all ask your questions afterwards.
Yeah, I mean, the generator and gearbox are up on the top. The rest, electricity comes down, gets fed into the control circuits and control equipment, and just gets sent up to the power poles.
I'll move the people.
Yeah, do that. All right.
This is supposed to give the data. Okay.
Yeah.
Where is the wind speed?
Oh, okay.
I could just look at it. I'm trying to find. Here we are.
Oh, okay.
Control circuits and power electronics. So the electricity comes down those wires right there and gets fed into the power conditioning unit, and then goes out to that green box, which is a transformer, and then up to the electrical wires.
That's direct current coming?
No, AC.
AC.
Three phase. So you have three different sets of, and we're putting out almost maximum capacity.
Oh, wow. What's the rating?
660.
Turbine is over a year?
Yes.
40, 50?
No, 28.
28.
Yeah.
Is that good for?
Yeah, it's just good, but it's good. Yeah, it's like good.
What's the minimum? It's like 25?
Minimum for a good wind project's probably 23, 22.
22.
Yeah.
So do you get any, what kind of incentives do you get through this?
There's federal and state incentives, plus just the commodity of the electricity. Yes. Well, I'm sorry it's so cold out.
That's okay. Are there any more plans to build another one here?
Yeah, we're gonna go to a restaurant and have a presentation by the officials in the town.
Okay.
So I don't want to ruin it for them.
Sounds good.
But yeah, they're gonna be looking at putting more in.
Is anything happening between now and restaurant, or should we?
I know, right? Come on in.
They should put the lid on top of the lift because it's easy to.
Yeah.
Oh, wow.
Yeah. So, and the electricity comes down these wires, these conduits.
Yeah.
It's 3-phase AC, so each one is coming down at 690 volts. And I was just showing the folks, it's pretty windy out there right now.
Yeah.
We're at 10 meters per second, which is about 20 miles an hour.
Wow.
And pretty close, it was just up a little bit further, but we're pretty close to maximum generation for a while there. Then you guys came in and went down, so get out.
Sorry.
So what do you...
If you could quiet down the generator a bit, put some damping there, I could live in here.
I know, right. Maybe... How was the rest of Wind Week? Was it good?
Yeah.
Guys, good.
So is this all smart control system? And all
Yep.
that kind of thing?
Let's see if we can get to the blade pitch. 11,000 megawatt hours.
Wow.
It's pretty amazing.
Yeah.
And it actually does use some energy as well. So the two of them give you a total. If we go back, let's see if we... So yeah, we're doing pretty good. And the rotor speed is pretty constant at 28, a little more than 28 RPM.
So were you at the presentations yesterday?
I was not. I was busy with another...
Because one of the guys talked about smart. And so all of the blades are on the same pitch?
No. No, they're all...
Individual control?
Yeah, they're all independently pitched.
Oh, wow. Okay.
Pitch.
So that's why.
A bit more.
Pardon? Right, like how...
When does it hit 660 kilowatt?
Yeah, we were pretty close there for a second, but it's gone down.
Yeah.
It's probably about 12 meters per second, and we were just around 11, and it was up around 620.
Okay. There you go, 6. There, you're on it there.
Whoa.
Yeah. Nice one.
Yeah. It's pretty neat.
Yeah.
For RPMs. So the generator, as you can see, is spinning much quicker. There's a gearbox there. And let's see, this is, the energy to date is 11 million kilowatt hours, or 11,000 megawatt hours. Not bad. And
How long has this been in production?
Right. If there's a major, maybe more than 10-degree change, it'll stop and then reorient itself. And that usually occurs in the mornings or late in the afternoons. You can control, you can stop it. A little bit, about 5 minutes ago. Yeah, it's pretty cool, huh? I want one. Oh, I got one. All right, folks, what do you think?
Does the new one have an elevator inside
No.
or so stairs?
Still has a ladder.
Because I know some have elevators now. I know some of them have little elevators now.
All right. So gearbox and generator, they're housed in the nacelle at the top. We're only at about 12, 13 miles an hour. Any questions?
As far as efficiency, how much efficiency from construction through generation is there for the massive units as opposed to sort of...
Machines generator might be in the batch that came out of the same manufacturing batch. So during the summer when our production's low, they just came and under warranty swapped it out. So now it's like having a
small considering the warranty for.
Yeah, it's about 30,000 a year for the warranty and another 30 for the insurance.
Okay.
Yeah, it's not bad. Very small compared to 2 million or to put it in, or not this machine, but in general, yeah.
What's the price per watt generating from this wind compared to like gas or like coal?
Well, that would be price per kilowatt, right? Kilowatt hour. I mean, kilowatt hour. I'm not sure, to be truthful. This might be generating at around maybe 4 or 5 cents a kilowatt hour.
It's pretty similar to gas.
Yeah. Yep. Energy generation.
So what's the wind speed up there? You were thinking it's only about 8 knots before?
It's 7.8 right now.
Holy smokes.
Meters per second.
Oh, meters per second. Oh, okay.
Yeah.
Right, okay.
But it's been upwards of 11 here, and while we've been inside.
I thought you said knots. I said no, it's blowing more than 8 knots.
Yeah, 8 knots is like 8 miles an hour, right?
Yeah,
roughly.
yeah.
Else want to get in that hasn't been in? Yep.
We'll see until you go about 10 yards.
Okay. Yeah.
Looks like almost like a
squiggle.
Yeah.
Oh wow. I'll have to let him know about that. Yeah. That's not good. A lot more about the offshore opportunity. So, Pat?
Good? Yeah. Okay. Good morning, everybody. Thanks for coming to our sunny Nantasket Beach with a lot of wind today, which we lucked out at. It's amazing how sometimes you can get wind when you want it. When Howe Wind 1 went up, obviously a project like that, you kind of pray during construction that you have no wind. And we were kind of blessed in last 2 weeks of December in '01 to have no wind. And it made the project go really well to be able to put it up with the cranes and everything. Got a lot of learning opportunities for the kids in the school. They were out there during the foundation doing calculations on how much concrete went for the foundation and how much steel and how high and all kinds of stuff. The teachers took great advantage of that. And as Domenico talked about how all these projects got started, really did start from the ground up. We, many years ago, had an 80 kilowatt turbine that was through a grant from the state that the schools owned, and over time, became decrepit and had to be taken down. And then Hull Light came along, decided to do it, but we were pushed initially from a gentleman called Malcolm Brown, who was just a citizen in the town and really was gung-ho about wind. And he had a little store down here that I used to hate when my wife would send me down there because I couldn't get away from the guy. He just wanted to talk wind, wind, wind. So eventually he got to a point where he came to the light board and we talked about it. He won us over, and it worked its way through. So became a reality. It was pretty scary stuff, spending $750,000 of ratepayer money, 10 o'clock at night making a decision like that. And, but it happened, and then years later, Hull 2, another success story, and now we're going towards offshore, which is a little more tedious project. As you can see, Harding's Ledge is where you can see the waves breaking out there. That's Harding's Ledge, roughly where the turbine project would go. And we're in the midst of doing a lot of studies. It's very dependent, obviously, like everything else, on money, lots of money. So we've just commissioned a firm to do a complete cost analysis of the project, which is very difficult because no one's done it in the United States offshore. So we have to make sure that it's really a doable thing before we go further ahead. The next study after that would probably be an avian study. And we've done a lot of geotechnical and all those studies underwater and gotten permission from the FAA, so all the steps you have to take. So we've been fortunate to get that far along, but the next thing is really key to find out, is this going to be able to sustain itself without rate increase and certainly in time rate decrease. We've got great community support. But once again, like I've always been saying, we're not doing this for the sake of building a monument out there. If it works, hopefully it'll get built if we can get enough funding. We're not going to pay cash for it this time. We just don't have that. And so at any rate, that's where we sit anyway. And if you folks would, from MIT, really enjoy having a nice place to have a learning center, I think Hull's a good place to come. So, and they would be in more of an arc fashion. We're told from the experts, you know, from any wind direction that they wouldn't interfere with one another. And on our lobster study out there by Harding's Ledge, we have learned that it's probably going to be in our best interest to move a little bit east and south of Harding's Ledge because there's a great number of lobster out there. And, you know, to avoid mitigation and stuff like that, it would make more sense. Plus, we located, as they call, a sand highway in these studies, which we need for installation of the turbines themselves, as well as the 34,000 volt lines that will come ashore. So you have to be able to plow those into the sand, so thus the sand highway will let us come that direction. A 12 to 15 megawatt installation, and we are a 14 megawatt town at our peak capacity. So we expect a whole lot of generation, you know, and the other issue there obviously is maintenance. And, you know, if one of these turbines goes down in, you know, middle of February, what's it going to take for us to get out there to get it repaired? And is it going to be down for a week because we're having a northeaster and stuff like that? You can lose a lot of generation now. So there's a lot of big questions still to be answered. But, you know, parts of days you can have a lot of electricity coming out of those units. As far as the offshore was concerned, it just kind of evolved that, you know, we could get a whole lot of generation more so than on land, because we're so land poor basically here. We don't, you know, it's a very tight community.